In this video, we're going to talk about the Pythagorean theorem and how we can use it to solve application problems with quadratic equations. The Pythagorean theorem is a theorem that relates the three sides of a right triangle. The two shorter sides of the right triangle are called legs. And in this instance, we're going to label one side, one leg, A. We're going to call the other leg B. And then the hypotenuse of the triangle is the longest side that sort of meets the ends of the two legs. We're going to let it be C. The longest name for the longest side, that's called the hypotenuse. And the other two sides are called legs, okay? And that relationship between the lengths of those three sides is given here by a squared plus b squared is equal to c squared. Okay, that's how they relate to each other. And when you have the Pythagorean theorem formula, if you know either two sides and are missing the third, or if you know a relationship between the three sides, you can often solve for the exact length of each one of the three sides by using that equation. Okay, the Pythagorean theorem is something you need to know, so you will need to memorize, if you don't already know it, that Pythagorean theorem for the test. Now, the first little example that I'm going to show you is going to be very similar to the one that you're going to see on the test. Okay, here's our question. In triangle ABC, the length of the short leg is 15 inches. The length of the hypotenuse is 39. What is the length of the third side? So let's put this together with a picture. You can draw the right triangle however you want to. Do remember that a right triangle is a triangle that has one right angle. In this case, that's located right there. A right angle is a 90-degree angle, okay? So our short side, the way I have it drawn, is this side that's over here on the left-hand side. I'm just going to go ahead and label that A. Okay, that'll give us a way to know where the 15 needs to be plugged in. So that's my A, and that's going to be 15 inches. I'm going to let the other leg be B. Now, that's the side I don't know. I know the shorter leg, and the hypotenuse, which is the longest side, okay? Hypotenuse is C, and this problem is giving us C to be 39, okay? So we have those two values, and we're missing the value for B. Now, we write down the Pythagorean theorem formula. A squared plus b squared is equal to c squared, and then plug in 15 and 39 for a and b respectively. So a is going to be 15 squared plus 39, I'm doing the wrong thing. We don't know b. Forgive me, I was just rolling through there. Plus b squared is equal to 39 squared. Okay, now take a second and go ahead and find 15 and 39 squared. 15 squared is 225, and 39 squared is 1,521. Now what you need to do is solve that equation so that b squared is on one side. We're going to put this in the form that we can use square root property or square root procedure to solve. That means we need the b squared isolated on one side and all of the constant on the other. So we'll move the 225 to the other side by subtracting it. 1521 minus 225. B squared is going to be 1,296, okay? And then you take the square root of both sides. Now, with the square root procedure, once you take the square root, you get a positive answer and a negative, plus or minus if you want to write it that way. But for this particular problem, since we're dealing with an actual triangle, and our A, B, and C are all lengths, then we are not going to have a negative answer. The positive answer will be the only one that we'll actually take. So if we were to take the square root of 1,296, we get 36. So B is equal to 36 inches. And that gives you that length of the longer leg, the length of the third side, the one that we're missing. Okay? All right, let's try another one. This one's going to be a little bit more like, well, actually it is, the example. It's in the book at the very end of section 1 thing. I want to say maybe example 7. I'm not for sure. All right, our next problem says a television screen measures 60 inches diagonally and its aspect ratio is 16:9. That means the ratio of the width to the height. Find the width and the height of the television screen, okay? So we'll start out with a picture. Okay, there's our rectangle, and the diagonally, the 60, oh, that was bad. The, I don't know if it'll let me back up since it's recording or not. Hang on. All right, let me pick back up with that. Here's our rectangle. Sorry. And then the diagonal, which is the distance between the two opposite corners, that's going to be your 60 inches, okay? This is your height. This is your width. And the problem is defining a ratio of the height of the width to the height is 16:9, which means for every inch or for every 16 inches that the television is wide, it's 9 inches high. And so what we can do is we can define the height then as 9 times x, the number of inches, and then the width can be defined as 16x. Okay, so we'll pull this up a little bit, and we set up our Pythagorean theorem. 9x squared plus 16x squared is equal to 60 squared. Okay, we need to do a little squaring to get some of those numbers straightened out. So the 9x squared is just going to give you 81x squared. And 16 squared is 256x squared, and then 60 squared gives you 3,600. Okay? And now, as we've done before, we want to combine our like terms, and then we're going to solve for the x squared term. So I need to add the 81 and the 256. That gives me, not a very round number, 337. 337x squared is equal to 3,600. And I don't think it said what to round to. We'll probably round to a couple of decimal places. On WebAssign, it should tell you what to round to if you're going to need to round, because there's a certain tolerance that WebAssign assigns to values that have to be approximated or rounded. So it should tell you on WebAssign if you have to do that. All right, so we're going to have 3,600 divided by 337. And you can either go ahead and do that division now, or you can wait for a minute till we do the square root. That might be the easier thing. That way you're not rounding twice. Let's just write it as the fraction for now. Then do the division and take the square root. And so what I'm getting for x when I do that, remember, we still only use the positive value for x because we are dealing with an actual TV, and these are distances we're measuring. So x is going to be equal to, if I go 2 decimal places, 3.27 is what I'm getting. And that's just x. So if we want to know the length and the width is going to be 9, excuse me, times 3.27, and the width is going to be 16 times 3.27. So let's see what we get. 9 times 3.27, I'm getting 29.43, and that would be in whatever units you happen to be working with. I don't know. Yeah, it did. It said 60 inches for the diagonal, didn't it? So that would be in inches. And then 16 times 3.27 gives me 52.32 inches for the width. And I just checked back in the book at the example, and they did actually round to the nearest tenth, okay, which is no big deal. That would be 29.4 inches for the length and 52.3 inches for the width it really doesn't make that much difference in this particular problem, especially since the instructions didn't tell us what to round to. We took it just 1 decimal place farther, so that's really not that big a deal. Okay, that gives you a couple to look at here. So you should be able to be okay on your book homework. There's not an awful lot of these problems in the book. WebAssign, you've probably got maybe 1 or 2. Again, remember on the test, it's going to be more like that first one that I did with the triangle, just the plain triangle. That'll be a lot easier than trying to incorporate it in with a television screen or, other story elements like that. So I think the one you do on test will be fairly easy.